All right, so 2.4 summary, techniques of integration. The two things we're going to talk about today are the product rule and the quotient rule. So your book uses some slightly different notation, and I'm going to go with what works for me. So for the product rule, f prime g plus g prime f. And then for the quotient rule, it's f prime g minus g prime f all over g squared. And those are the two rules. So it's going to be our product. And the way it's easy for me to remember is that product is really adding a bunch of stuff together, and quotient is going to be what I use for difference. So I think of logs and things like that, where when you multiplied logs, you could add them. When you divided logs, you could subtract them. So for me, it's just an analogy that works in my brain. Your book uses slightly different notation. It does g prime f plus f prime g for the product. And just, I would ask you to take a look at it and note that when you're adding, order doesn't matter. But the way it works for me, if I do it this way, the notation, they look the same. The only difference is the subtraction and the division here. So for me, I always do it the same way, okay? So product and quotient rule, two key concepts for derivatives. So let's take a look at the product rule, and let's just do an example. And we want to start with something that's in our book because we want to get familiar with it. And the notation in our book sometimes is a little odd, but that's okay. We're going to do an example straight out of the book. I'm going to go ahead. This is number 6, straight out of the book. Number 6 says 2 minus x minus 3x cubed times 7 plus x to the 5th. Okay, so what we want to do is we want to break this up into two pieces. So I always call the first piece f, and the second piece is g. Okay, this is just for notation. Yes, these two components that I'm calling f and g are part of this big function, which is f, but it doesn't matter. Okay, it's just notation. So now I want to use the rules from earlier in this week, from section 2.1, 2.2, 2.3, to simplify f. So I want the derivative of f, and I'm going to get negative 1 minus 9x squared. And then I want to come over here, and I want to do g prime, and I want to take the derivative of just the g, and I'm going to get 5x to the 4th. So now I do this every time just because for the first few times it helps keep things in order. F prime g plus g prime f. So I'm going to take f prime, and I'm just going to direct substitution. And I'm going to multiply that by the original g. And I'm going to add to that g prime times the original f function. And for all intents and purposes at this point, I've done the hard work. Now it comes down to foiling distributive property and simplifying. So negative 7 minus x to the 5th minus 63x squared plus minus 9x to the 7th. Add to that 10x to the 4th minus 5x to the 5th minus 15x to the 7th. And then I just want to go ahead and combine like terms. So I have a negative 9 and a negative 15x to the 7th. So that's going to go ahead and give me negative 24x to the 7th. And then I have negative 5x to the 5th and negative 1x to the 5th. So negative 6x to the 5th. And then I have a 10x to the 4th. And then minus 63x squared and minus 7. All of this right here is equal to f prime of x. Okay, f prime of x. So when we do the product rule, we need to make sure that we identify the first term and then just take a look at its derivative. Then we identify the second term, and we take its derivative. Okay, let's do another example. So same section, 2.4. Let's go ahead and do same section, 2.4. Let's go ahead and take a look at number 9. Number 9 looks like this. X minus 2 times the quantity x squared plus 2x plus 4. Okay, so that's the original problem. Now we want to go ahead and call that f. So now I need f prime, which is just 1. And then I want to go ahead and take a look at the second piece, which is g. So I need g prime, which is going to give me 2x plus 2. And remembering the formula, f prime g plus g prime f. And so what we want to do is we want to take the derivative of f, which is 1, and multiply it by g. And then I want to take the derivative of g. Notice the parentheses, because that's a quantity. And I'm going to multiply that by x minus 2. Now I'm going to FOIL. And now I want to combine like terms. So 2x squared plus x squared is 3x squared. A positive 2x and a negative 4x is negative 2x plus 2x is 0x's. A plus 4 and a minus 4. And so really, my final answer is 3x squared. Now that seems odd, but let's see if we do the derivative by FOILing it first and then see if we get the same one, or maybe we'll just skip that today. Let's see. I want to make sure you understand the notation. So I'm going to go ahead and leave this one. I won't do it again because once we've done it once, you can see it's a lot of work. If you want tomorrow in class, you can ask me to work number 9 by FOILing it out first and showing you that you'll get exactly 3x squared. I will do that tomorrow in class. Okay? All right. So now what we want to do is take a look at the quotient rule. Now the quotient rule is anytime you have a function and you have some numerator and then you have a denominator. Okay? And again, we're going to call the top f and the bottom g. And just because that's conventional wisdom, for no other reason. I could call it S and T, P and Q. So what you're going to hear me say is derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Okay, so think of G as the ground, the ground, the ground, the ground. So the one on bottom, doesn't matter. So we're going to do an example. Your book, remember your book will use notation like this, the derivative of f times g minus the derivative of g times f. Okay, remember this d dx is really just saying take the derivative. Okay, the derivative of with respect to. Okay, so when you see this in the book, don't freak out. Okay, because really this is what you need to be able to do. Okay, top, bottom, bottom, top. All right, so I want us to go ahead and do an example. And so we're going to choose this straight out of the book from the very early problem sets. And I'm going to go ahead and I'm going to do number 12. So number 12, and this is on page 168. So grab your book, open it up, go to 12. You can write this down. You can pause if you want. Okay, so x minus 2 divided by the quantity x squared, plus x plus 1. So this is f, and this is g. So f prime is 1, and g prime is 4x cubed plus 1. So I'm going to go ahead and write it, because we need to write it. derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Now, because I've labeled everything f and g and f prime and g prime, I should be able to just substitute in. So the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay, that is the derivative. So now we need to FOIL out the top and simplify. The bottom is going to stay. I can't factor, I can't simplify, so we're just going to leave the bottom. But on top, minus. Now I'm putting brackets because the minus sign is going to apply to everything after it. So 4x to the fourth minus 8x cubed plus x minus 2. Remember, that's all after the brackets. The bottom remains unchanged. And now I want to simplify. X to the fourth plus x plus 1 minus 4x to the fourth plus 8x cubed minus x plus 2. And now combining like terms. And remember, this is really going to give me the derivative of my original function. Footballers are coming in. Oh, hurry. Combine like terms. Negative 3x to the fourth plus 8x cubed. X and x go away. 2 and 1, now they're banging on the door, is 3. And then on the bottom, we're going to leave it. You guys have awesome football players here on this campus banging on my door, trying to get in here while I'm recording. You can yell at them tomorrow. Okay, so that would be the difference quotient. Now, football is trying to come in here now, so I'm going to go ahead and be done for now. But I would strongly encourage you to write these on the top of your paper. So f prime g plus g prime f, where f is not top here. F is first term and g would be your second, okay? Keeping in mind that f is your first and g is your second. For the quotient rule, derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Okay? Those are the two rules. You have the problem set. I gave it to you actually Monday in class, which is today when I'm recording this. And you won't actually watch the video for 2.4 probably until tomorrow night. So when you come into class on Wednesday, when you come into class tomorrow, your password is going to be football. Password for tomorrow, football. Have fun.